addressing security issues from members of Géance. It's a pleasure to welcome the first one of those two speakers, is Gerard Frankowski. He's from Poznan, from the PSNC security team. And he's going to be talking about addressing complex security requirements for network services in multi-domain environments. So, Gerard,
thank you, David, for introducing me. Welcome, everyone. I will tell you about handling security for multi-domain services in Géant project. I will start already with technical issues, with a very short reminder on how the security issues look nowadays, that they are complex and that there is also a complex approach named defense in depth, which is considered as the optimal way to combat with contemporary IT threats, and how we have attempted to adapt that approach in our multi-domain environment within the Géant project. As you can see on the right part of the slide, within the task SA2 task 4, we have got a number of different activities. Some of them interact with others. We have got different measures, proactive ones, reactive ones, and I will shortly describe all of them to you, and we'll try to show how they complement each other to build a consistent and complex security layer for multi-domain services. At the end of the presentation, I will make a very short comparison with two other research projects that I have participated in to show how we try to learn and to gain new experience with each research project to go to the optimal security solution for such research infrastructures. So as for security threats, it's very easy to make such an introduction because we know from numerous sources that we have got many security vulnerabilities, many new services, many new systems, many new users, that today's IT infrastructures become more and more complex. See, when you are going to use a website, you have got a browser on your computer, you have got a web page, there is some scripting language that builds those pages, there is a web server, database server, underlying operating system on the server, we have got networks, firewalls. We can consider those things as layers, and on all of those layers you can have a security misconfiguration, a security bug. Unfortunately, nowadays cyber criminals think economically. They no longer want to prove their skills to someone that they were able to break into the system, but they just want to steal something, to steal some data, some resources, to make a botnet, to make large DDoS attacks from the compromised machines. All that may be directly or indirectly translated into some value, some money. The next bad thing is that today's software is so complex that actually we can't avoid security vulnerabilities in it. It is in theory possible. You can mathematically prove that your software is perfectly correct, but you have no time and no money for that. In software that you use, especially if this is a software not produced by a large vendor, but for instance implemented by a group of people in a research project, you will have some number of security vulnerabilities. And we are going to minimize that number to make those security bugs as hard to be exploited as possible. Within the Géant environment, we have got another dimension of this complexity. Because the Géant project involves about 30 NRENs, NREN stands for National Research and Education Network, and some other entities like Terena and Dante, you can easily imagine that in all this organization there work little bit different people with different experience, different good practices. It can bring some sort of inconsistency in things that they do when combined together. It also can bring some danger, and we also are going to address that. In general, it is assumed that approach called defense in depth is the optimal way to secure complicated IT infrastructures. Because if you have got a number of layers where you can have security bugs on all of these layers, you also can put security systems on different layers. Different classes of security systems are able to detect different vulnerabilities. So if you combine a number of security layers, even if an attacker is able to break into the layer A and the layer B, you can still have a layer C, E, and D that will probably stop the attack. Another thing is that the more security layers, the harder is to successfully break into the system. The attack takes more time, more money for a potential attacker, and as the attacker thinks economically, it increases the probability that the attack, even if successful, is not profitable for him or for her. Another thing, if the attack is more difficult, more complicated, the probability that you are able to detect that attack with your monitoring, your logging tools, also increases. This is especially important in environments like multi-domain services in Géant, which are highly heterogeneous and distributed. As I have said, different people working on that. Another important aspect, you can't provide security at the very end of the life cycle of your system or software or infrastructure. It is too expensive and inconsistent. Who makes security work for multi-domain services in Géant? What is multi-domain service? All the Géant project is about providing multi-domain services within the large Géant European Research and Education Network. Multi-domain service tool is a tool that you can use for your purposes to utilize multi-domain service. And multi-domain service is a service that involves at least two entrants. For instance, bandwidth on demand that you can see here on Terrena, it's start, I don't remember correctly when. And there is a security task, SA2 task 4, which is named Multi-Domain Security Team, that takes a look at security of multi-domain service tools or MDS tools. And there is security governance at absolutely different point of view, and Branko will tell you later about this point of view. And our both tasks make things to the purpose, to the benefit of people who implement MDS tools to SA2 Task 5 programming experts. The first part of our activities is a reactive one. If there happens a multi-domain security incident, which is a security incident that also involves a number of entrants, we have to handle that incident. And handling the incidents is the main thing that CERT teams in entrants do, isn't it? But as we have got different entrants and different certs, probably each of them uses some standard for classifying incidents. They have got their own procedures for handling incidents, own communication facilities. But again, these are different certs, and from the point of view of a particular cert team, it is absolutely perfect that they use procedures, standards, and so on. But when we combine together a number of certs, it may happen that from the general point of view, those procedures are different, inconsistent. And therefore, handling of the incident becomes non-optimal, takes more time, inappropriate person may be informed, and so on. That's why we have established in SA2 Task 4 a virtual security team that groups CERT and run experts from the project members that participate in the task. And this virtual security team derived a special workflow, a special document, a procedure, what exactly should be done in case of a multi-domain incident that occurs in MDS tools. The goal of this document, of this procedure, is to clear out those potential inconsistencies, to make a security incident being handled in the optimal way. And to support that goal, we have established also a knowledge base to store knowledge about incidents, to store contact data, information about security incidents that have already been handled, to store standards, procedures, and so on. To have a consistent source of knowledge where each NREN cert involved in multi-domain services protecting can take and can see what should be done by whom exactly in which particular case. Our knowledge base is based on, I think, well-known software, RTFM. Now I'm going to take you to the part that starts involving the developers. I will start with fire drills. Fire drills are a direct measure to validate, to check if our procedures and workflows are correct, if they work okay. A question may arise why it involves developers. Because we have got different scenarios. Fire drill actually is a simulated attack, so we don't make a real attack, we don't send a real malicious traffic. For instance, during a fire drill that has been run some time ago, we sent a network packets with some particular short text embedded with them, but it was not a DDoS attack, it was a network traffic that had to be encountered in a monitoring system, and the whole procedures were run. And we have got different scenarios. For instance, DDoS attack compromising the system or hosting a phishing site. And if we have got a scenario of compromising a system, it will be tested, the case where the cause of compromising that system is a critical security bug in one of the MDS tools. A critical bug that developer could make, because remember, it will be an exercise. So it will not be a real vulnerability, but we will test the case where it is. So appropriate path within incident handling workflow will be used to inform the involved software development teams that there is a critical security bug and you should immediately apply a quick workaround or implement a patch and distribute it to the clients within Géant. But of course, it will not always be the case, so involving the developers in fire drills is an opportunity, but is not mandatory. The second thing I want to talk about is risk assessment. And it might be interesting because we cooperate with developers and the deployers in assessing a general level of security of multi-domain services. The definition says that risk assessment is a method for identifying and managing threats that might negatively impact our multi-domain services. And how we cooperate? Security specialists from SA2 Task Force have prepared a web application. That web application contains a set of checklists. CL stands for a checklist. And those checklists are not do not contain questions that can't be answered by the developers. There are simple questions. For instance, for a deployer, it might be the question, what version of Apache Tomcat do you use in your deployment? For the developer, it might be the question, have you implemented an authentication mechanism in your MDS tool? There are general checklists, there are checklists for particular MDS tools, and the scenario is that deployer or the administrator comes to the browser, runs our web application, selects checklists, answers, submits the form, and the form is sent to our internal server. Basing on these simple answers, the overall score of risk assessment is calculated, it is displayed to the developer and saved internally, to be controlled by security specialists. And after we can see the score, it is possible that bidirectional communication will start. For instance, the developer may ask security specialists, why my MDS tool has been assessed so badly, why there is red, why the risks are so high. On the other hand, a security specialist can ask a developer, hey, I have seen from your answers that you still have not implemented authentication mechanism. We should do something with that. And we will cooperate with each other to to build such a mechanism and configure it. As for the score, security metrics is usually a large problem because too many factors impact security. But we consider the risk assessment rather as a general view on the MDS tool. We don't have to see from that risk assessment that we have got 17 security vulnerabilities in the source code, but we want to know that the situation may be bad or may be good. This is only a general risk assessment. If we see from the general assessment that there may be security problems within the MDS tool, we will use other measures like penetration testing to exactly check those risks. That's why we have developed a custom, very simple metric. We have divided MDS tool with its environment onto 3 categories, and we assign from 0 to 5 points within each category. There are cases when you are awarded points, which is not good because the higher score, the higher risks, but there are also cases where you can be subtracted some points. For instance, if you had additional security measures implemented. The next part is about detailed testing, also validating of the risk assessments that I have just described. The next part starts with Security Cookbook. The first version of Security Cookbook was intended as a set of links for the deployers and the developers. We have divided a security area into about 10 sub-areas like network security, monitoring, and so on. And for each particular sub-area, we have provided a set of links that lead to web pages containing very basic best security practices. So again, not on a technical level that the deployers or the developers would not absolutely understand it because it's too technical only for security people, but with general good practices that we think they should know. The second version and the next versions of Security Cookbook contain issues that have been actually enumerated during penetration testing or during source code review of MDS tools. Source code reviewing is a great tool for finding security vulnerabilities in particular software. Each issue is described, it is structured into a form of a table where we provide a description, severity, associated threats, and recommendations. Whenever applicable, we try to provide different versions of recommendations. For instance, a quick workaround and a more thorough change that requires rebuilding the source code and may be implemented during the next release of the software. Another measure for identifying real security threats are penetration tests. Penetration tests are very nice for us because you act as an attacker during testing particular service. These penetration tests are not mandatory, are on demand. I can say that after the first security audit, the development teams of other MDS tools are glad to have security audit, but it's not mandatory. And we also have to say that we use a standard approach for penetration testing, but only to some extent. Remember that we are people who protect MDS tools with their environment, but not the NRAN infrastructure. The NRANs have their own security teams, and this is beyond our scope. So if we find a bug in MDS tool, the most important thing from our point of view is to block that vulnerability. It is not important for us if we exploit that vulnerability, we would be able to attack 10 or 100 further systems. It's beyond the scope of the task, although it's important from the point of view of penetration tester, but not within our project. There will be situations where penetration tests of the same MDS tool will be performed by different people. We have got a number of security experts in SA2 Task Force that may do that. To assure appropriate consistency between those tests, as each pen tester likes different tools, has got a little bit different a little bit different things to do, experience and so on, maybe sometimes also the skills. We prepared a set of checklists. A checklist is intended to cover a basic set of tests that should be run whoever does the penetration testing. We have identified a number of security areas, you can see them, and we are providing those checklists for pen tester teams. If they find that the checklist should be extended, they are also encouraged to do so. The last part, direct knowledge transfer to the developers and the deployers. Security consultancies. We provide a service for anyone who wants to ask about a security problem, of course associated with multi-domain services within the Giant. As you remember, security areas that I have mentioned during describing the cookbook, we have got exactly expert for those security areas within Security Expertise Consultancy Service. You can ask about network security, and host security, about monitoring tools, about policies, procedures, and so on. There is a dedicated mailbox. You can drop us an email, and a person who is responsible for looking at this mailing list will see to which particular area the given request should be assigned, and informs an appropriate expert. We have got at least 2 experts, a primary one and a secondary one. In case a primary one can't respond because, let's say, he's absent, the secondary expert will take the issue. And another measure to transfer the knowledge is secure coding training. I have left this activity to the very end because I think this is the most important one, the most proactive one, because if we train the developers not to make so many security bugs in the source code, then we will have less multi-domain security incidents to be handled. That's why we provide a quite large amount of knowledge every year. We organize secure coding training for at most 18 participants in order to make the training the most effective for them. 2 years ago, we have built some kind of a foundation on the first secure coding training. We have provided some introductory issues, theoretical introduction, why security of the software is important, why there are bugs. And now we go into some more deep technical topics. We provide practical workshops, hack me contests, static source code analysis, and many, many more. Usually the persons who attend the source code training are the same persons. The number of developers in Giant is also limited, so we don't have a need to repeat those introductory issues. This was our offer and for the deployers and the developers. Now a short comparison with 2 security projects I have experienced. The first one is Polish research project named ClusterX. It was started 9 years ago. Security was very strong within that project, and I would say even we can ask whether it was not overestimated. Indeed, security was strong. For instance, we had got an opportunity to dynamically attach and detach additional clusters to and from the infrastructures. We have prepared a long list of requirements for such a cluster and a specialized procedure to do that. However, both the requirements and the procedure were long, and probably because of that, not so many users used that procedure that could. So the balance between security and usability was not optimal in that project. It was better in the second mentioned case in the Polish National Grid Initiative, PL Grid, that has just finished. There was also a dedicated work package for the security. What was very significant, the work of this task started with organizational work, with deriving procedures that were then used throughout the project life. The project center, for instance, had got a right to reject the deployment of the software in which there were found security bugs assessed as critical. Project management board could reject that rejection, but taking the full responsibility for that fact. Another thing very important, that security assessments were formally built into the software development lifecycle, which is not yet the case in Géant. But also in this project, there are things that could be optimized, and we propose that optimization in Géant. An example might be that in PL Grid, sometimes it happened that similar security bugs were described in a different way by people from different teams, from different project members. In Géant, we propose a consistent format of penetration testing report, which should remove these inconsistencies. To shortly summarize, we think that as the threats are complex and our infrastructure is complex, we should also respond to that with complex security measures applied to multi-domain services. And we provide a number of security countermeasures. We have got reactive and proactive measures. We address the deployers, we address the developers, and we address security incidents that might happen. We hope that this model is at least close to optimum. What could be optimized, formally building security assessment into the software or infrastructure development lifecycle. But this is one thing. And we hope that this model could be discussed in the case of other research projects, because the resources are limited, but within the project. But we have selected a number of security components that we hope fits our resources in the best way. This was all from my side. If you have got any questions, please ask.
For one or two questions, if there are any. I can't see. Is there anybody? So maybe I could just ask, do you have a mechanism by which you measure the effectiveness of some of these security approaches? Have you been able to see things improve? Or?
I can say that we expect such a mechanism, but we also have to understand that the project is running and the multi-domain services are just being released. As far as I know, the bandwidth on demand is run here on Terena, is shown for the public. And also we have finished our mechanism not so long ago, but we expect such mechanism, for instance, in risk assessment. If we combine consecutive releases, scores for consecutive releases of MDS tool, we expect to see decreasing trends, that the risks are decreased by the knowledge that we provide to the developers. They will make no more security bugs. After the project ends, we will also see how many security incidents we have suffered. We hope 0, but it also can't be said just now.
Thank you.
Thank you very much for your attention.
Nothing else? Let's thank Gerard again. So we now move to the final talk in this session. And this is a pleasure to welcome on stage Branko Marovic. He is from the Belgrade University Computer Center, where he's leading the Center for Software Development. And he's going to tell us about another aspect of the security lifecycle in Géant. He's going to talk about bringing governance into distributed R&D software development. So when he's successfully wired up, the floor will be his. So, Branko, please.
Thank you, David. So, I'm about to present you the work that has been done in Géant in a field that is related to what Gerard was talking about. Our goal was to introduce software governance into software developments within Géant in its third iteration, Géant 3. Software governance is about providing efficient development and quality in software products that are produced. The problem that we had is complexity of organizational structure between developments, because we have independent and distributed groups of developers who are managed and coordinated by their own NERENs and also by software project managers. Also, the complex where the results are applied is rather complex and distributed. It's a multi-domain Gent network. So these service products or projects basically stand and partially are responsible for three groups of services that are provided by Gent. They are connectivity services, network performance and operation services, and end-user applications. In all these developments, it was realized that there was a need for a consistent development methodology, management procedures, and common set of tools. Therefore, a new activity, software governance, was established in Gen 3, which is independent from the actual developments and is directly responsible to the project officers. It's split into three tasks. One is best practices, which is about collecting and publishing and promoting best practices on software architecture, developments, and quality assurance. The second is development infrastructure, which provides and maintains common infrastructure for developers. And finally, quality assurance, which verifies and supports application of best practices and also the use of common development infrastructure by performing periodic audits of all software projects. The problem was that most of these software developments had some history. They had their communities, their development tools, and we had somehow to sell all this to the development teams. Therefore, we performed a survey on their own practices, technologies, issues, and also their expectations from our activity. By doing that, we basically ensured that we don't miss the target, that we get some feedback from the developers, and therefore we got better chances to match their needs and to push them a little bit forward. We realized that the most of developments have been done using Java, mostly enterprise platform, that there were sometimes not slight differences in practices and tools, that there were many overlapping and similar efforts, that sometimes some kind of integration between all these developments was required, which led to certain problems. And although all teams declared use of agile methodologies, the actual application was inconsistent. And of course, every project has its own infrastructure, which resulted in effective usage of manpower maintaining it, and also inadequate and inefficient access to the code and documentation, especially when you have a person who migrates from one development to another. All projects had strong interest on guidelines on coding, testing, deployment, but also on support. So they expected technological pointers, conventions, and lifecycle management guidelines. The first task, best practices, provides guides for software developments which would allow them to find a common path across individual developments and methodologies within developments. So we intended to provide some common sense sometimes basic, sometimes not, wide-ranging and informative guidelines. We needed to also to support both programming process and related development procedures, but also things like access to the and usage of support infrastructure, and support things like migration to support and operations or closing of projects. These best practices have been split into 3 guides: software developer guide, software architecture strategy, and quality assurance guide. Here are some of the topics which are basically the key areas of these best practices. So I won't read them, but you have them for the reference. This is what basically the developers are interested about. When it comes to quality assurance audits, they're performed every 4 months, and they measure projects' progress in terms of alignment with best practices, use of common tools and the infrastructure, and they track, and these audits track progress through in advance defined metrics. These audits resulted in a number of recommendations to the developers. And also some issues were identified that were not addressed by the activities or were related to later phases of software lifecycle. We had to address the issues in best practices and in the infrastructure activity task through their updates. Here are some charts from the audits of CNIS, which we can see the progress of this project through 3 audits, and it's similar with other ones. Recently, the 8th audit was performed, where there have been also some changes. So we see that basically all these metrics are getting improved, but however, almost each one of them basically has one. It's done on effort basis. When the developers emphasize one aspect, it gets improved between the audits, but then it stalls for some time. So it happens basically in all projects likewise. So you have to constantly push. The software development infrastructure is based on the mainstream development tools, something that, what people know and want to use. It's shared across all distributed teams, and it's a set of services. Some of them are based on open source software, some are proprietary, but they are integrated through shared authentication and authorization service. And then there is a subversion as source code management platform, which is something crucial and basic. Then there are tools for code browsing, online code browsing and reviewing, distributed reviewing by humans. Then we established a repository of artifacts, which is used by Maven build tool. Then issue tracker, then collaborative wiki, which basically allows integration of all documentation and artifacts. Then continuous integration platform, which also has plugged in static code analysis tools. So at every day, the projects can track what is the actual state of the source code. And finally, the last thing that was established is a license checking tool, which basically helps our IPR coordination activity. So here we see how how these tools, which are columns, have been adopted by different software developments. Okay, the only major problem here is that Perf family of software developments mostly does not use our software repository because they have their own long-term arrangements which they couldn't miss. In this process, we adopted a gradual approach in terms of incremental alignment and continuous detailing of the initial recommendations, and by addition of more and more advanced and integrated tools. So we also worked towards mapping of recommendation on the actual use of common tools, because developers think in terms of tools, of software, aids, which basically help them adopt some practices. And the governance itself is aligned with the principles of agile methodologies, which it promotes for software development. So in that sense, we are basically eating our own food. And we heavily rely on feedback from developers and their demands and evolving needs. Also, quality assurance activity provides another source of information on what we need to do in order to evolve. As we at one point felt comfortable with all this framework, we decided to adopt more proactive attitude. So we moved towards guidelines that would lead teams into transformation of their developments into reliable and real products. And we were working on facilitation of knowledge and experience sharing among these development groups, because we already have a relatively small groups of developers in individual projects which work in a distributed manner. So we had to find some way of them exchanging information and getting some sense of community. And we also performed 2 in-depth audits of software quality, reliability, and efficiency, and with help of software expertise delivery Gerald were talking about. There was also there were also security audits. So there are basically, these audits are somehow addition to these regular periodical audits. And we also provided the support to the project office by deploying the tools that verify compliance with the GEAN's IPR policy. The mentioned community events are summer developer schools where developers mingle, actually they network, exchange experiences, learn some programming practices, and solve common problems together. So we had this strong, problem-oriented approaches where we have real-time examples and real-time problems to be solved through hands-on sessions. They're also related and targeted to tutorials, which are related to the later hands-ons, and people work in groups of 3 or 4 on prepared tasks, which are on the subject of this summer school. People during these trainings also use the actual development infrastructure, and later they are obliged to present their results, to defend them, and the best ones get some awards. Basically, these are vouchers for buying some technical books. And we also provided small contributions to security-related trainings. Here are some photos of our summer schools. So these are mostly young people coming from across Europe. We also introduced QA persons because we realized that not all QA recommendations were implemented. So these persons are first line of support for each development. They are advisors to the project teams. They observe the process, investigate and try to also sense potential issues, and then report their concerns to lead developers. If some of these issues is not solved internally, these persons communicate and exchange opinions with other teams and available experts, our activity included, and therefore, try to mitigate possible problems. Mentioned in-depth audits have been performed for 2 applications in development, and they were on subjects on architecture, code, reliability, and efficiency. But one of them, the team managers also wanted to hear about some possible improvements of software development management. There was also a participation security audit that was led by SA2 Task 4 for the application that was migrating from piloting to operational usage. And in these audits, QA persons served as liaisons between auditors and developers. Auditors came from outside. So these audits were basically on specific topics and were performed on completely different way than the regular audits. We have also recently established a so-called QA test bed, which is infrastructure for demos, testing by developers, but also for quality assurance teams, which are not part of our activity, but they basically manage transition into next release. This infrastructure consists of a number of virtual machines. They share storage. There is a method of long-term reservation for demonstration and testing when these machines basically stay dedicated, or scheduled pool for distributed quality assurance testing. Because sometimes you need to address and relate to all this multi-domain distributed network in order to test something. We are basically building a stage environment where the people will be able to stage their software projects through development, integration testing, acceptance testing, staging if needed, and then move into production. And of course, if there are some problems, there is possibility to arrange stress and volume testing. So this is how it looks like. We have basically a set of virtual machines in these 2 sets, which are using common services mentioned before in order to deploy the tested software, and all this is mapped on a set of physical machines and shared storage. There was also a large problem in relation to IPR, because people are hired by a number of entrants. There is a history behind the projects, and it took quite some time, more than 2 years, to define the GENT's IPR policy through a separate coordination activity. We then introduced a tool which can interact with continuous integration and by builds by Maven, which basically tracks the licenses of both build software by identifying license patterns within text artifacts, and dependencies, which are basically used packages. We had our own repository of licenses that are allowed and forbidden by Gent IPR, and therefore it's possible to dynamically verify whether some licenses, whether IPR is dealt with in an appropriate manner. So, to conclude, software governance had, we hope, strong impact on software developments in Gent project. And it is interesting that we had a unique opportunity to basically observe a number of software projects and to influence them at the same time. It's usually not the case, and if you study the literature on the subject, you will learn that the most of papers are dealing either with, for example, evaluation of the history of some open source projects by, devising some methods of estimating complexity and effort based on source code history, interviews by project managers, and so on. Or they observe influence of some intervention, like, for example, introduction of agile methodologies on a small number of developments, 1, 2, or 3. In this case, we had a complex setting, and we had opportunity both to consistently monitor and to influence at the same time. So it's a quite interesting experience. And also, we didn't simply try to dress Gent into a single prescribed methodology and to follow some kind of, to evangelize something that is written by somebody outside, but we were trying to find some kind of middle path that was most adequate for our developers. And we saw through all these tasks within Gent, we covered both everyday procedures in terms of best practices, then performed some kind of formal processes, which are actually audits of the software projects, and provided support resources and activities through the infrastructure. We also later tried to address difficult underlying areas, which are identification of people's needs, motivating developers to actually apply the guidelines, perform training, and stimulated exchange and sharing between developers. So this activity obviously produced some measurable results, and we think that similar approach could be applied in other similar large-scale developments. So that's what I was planning to say, but if you have any questions, I will be happy to answer.
So do we have any questions? Everybody's anxious to get
Okay. Lunch is near.
So if there are no questions, let's thank Ranko again. Thank you. So for those of you who didn't hear the announcements after the plenary session this morning, there are a number of short announcements. There are demos during the lunch break in the demo room, which you will find behind the registration desk. Check the agenda to see what's being proposed there.